So we're gonna do a bit of a go on with a copy pasting, I guess. So yeah, I kind of feel like I'm not really I'm not this kind of person that easily finishes things. That's not necessarily good. So we're doing yesterday. We're doing better quantum counting. This is this thing here. So and I got stuck with the multi-control Z. Good. I also started on the side the Simon generic implementation of the Oracle. That it's actually an exercise from the Qiskit textbook that I didn't really do, and that a viewer, Tom Kruger, basically brought up on a comment, and I'm so kind of working on these as well. He's got a solution already, but I just wanted to kind of go through the exercise myself. And I just okay. I'm also stuck with Rubik's sphere circ because I'm getting the opposite result that I should. So this is something else that we need to debug. And let me put my face over here. Good, maybe over here. And then basically, and the fields analysis is a new thing. So what I can do is I'm going to copy paste now. So I'm just don't have much time anyway. So just let's copy paste import some of these things. So this is the simulating a logical qubit project. That's this guy here. And I'm not sure what I was doing. Was I using circ? Yeah, I was using circ. That's cool. Okay, so I'm going to copy some of these things in here. Let's see, because I was trying to. Okay, so I was actually already building a class even. Let's, my imports are awful. And you know what's kind of cool about these is that what I really like is that the project is not just the code, right? So if I basically, so this is the, I'm not gonna do it this way. Because then I have to import all the stuff every time. So if I do this, the simulator, measure, I'm just gonna leave it this way. And what I was saying, so this was just, I was just playing with the idea. And so I think what I got to is to this class. Yeah, where I was actually, exactly. So it's going to be an easy one. So basically, can I make my face smaller? Yeah, I can put myself here. Cool. So I was basically playing with this class. I need to, can I, I'd love to be able to multiple select. I'm not so sure if you can do that with this editor though. But I can basically, so I have to kind of add these all over the place now. I didn't import those operations separately, but it doesn't bother me. So this is basically Shor's error correction code, and what I was working on is trying to simulate a qubit with this. So a logical qubit. So the idea would be that to have a function that would kind of, given a circuit, will shield it with Shor's code, and just have the whole circuit in between the first encoding and the decoding part of Shor's code. And so I was kind of like, yeah, here in the middle. And then I was playing with the idea here of printing the layers. So the encoding layer, the Hadamard's layer, and the decoding layer. And the reason I was doing a Hadamard layer in here is because I realized I kind of have to Hadamard sandwich the code for this to work well. Let's see if that works just out of the box like that. And I'll show you what's cool about the project space. Okay, so it's not working. Circuit. So what have I done? Run circuit. Why isn't it working though? What's the problem? Invalid syntax. Def run. Yeah, that's it basically. How is this running at all? Self edge layer append. Yeah, okay, H is not. So again, that's here. I'm gonna add the circ in here, run the code, can delete results. Come on, I'm missing another thing here somewhere. H. Where else? Where's these? Line. Qubits is not defined. Qubits. Should I add self? I think so. So then I probably should add it all over the place here. Okay, so what I'll do is fine, and I'll just how do I? What? Sorry, I just reloaded the page. No. Okay, but I think I didn't lose anything. So Control F is fine, and this is replace. And so I'm going to replace qubits by self qubits. And I can just replace all. This is gonna replace, yeah. So I just gotta then fix this one where we don't want this here. The rest has it. Problem. That's the thing with notebook. Oh yeah, nice, cool. Okay, so we got it. Cool. As far as I remember, you can, if you use Strangeworks print. So if I use Strangeworks print, I think that goes somewhere else. It's pretty cool as well. I think that goes to the output, but in Strangeworks. No logs code run. No, I thought this was being caught differently. Okay. I have to read the documentation. But I think there's a difference. There should be a difference between the print, Strangeworks print, and yeah. Cool. So this is these, and then okay, so this is kind of done, I'd say. What is cool about this is that you've got basically here, right? You can add, what can you add here? You can add folders. That's cool. In here, you can add, what is these? Just files. You can download the whole thing, and here you can write documentation. Now, I think they're changing that, but it's basically Markdown. I think they're going to change that, so don't take these as something serious at the point at the point of filming these or shooting these. Test title. Let's see how this works. Test title. Hello, documentation world. Save, because I know that the way this works is if I share the project, if I get a sharing, like a public link, right? Which right now it would require you to actually have an account, right? I can see how this looks like here, and I can. What if I? Okay, you see, that's cool. So you basically see, okay, simulating a logical qubit published by uncertain systems, and then you've got the documentation in here, and actually you've got the project code. Oh, that's nice. So this is a really neat way to share stuff, and you can add this project to your own project library. So you kind of can, sort of fork these and play with it as well. but you can here basically add any documentation that kind of maps to your code and or explains a bit the code. So that's something that I'll be working on as well at some point. But that's pretty neat. I'll have to. I'm not gonna basically. I'm gonna unshare this. Can I? Yeah. Can I just make it private again? So yeah. But I've been told that they're gonna change the way this works a little bit. And so I don't want to now invest too much on the documentation. Other projects will do this later on. Okay, so we're done with the so we're stuck with better hunting. We're done with the logical. We're done. I mean, I kind of copied it over. So this is okay. And now if I go up one folder, Grover Nisk. So here, this is going to be a bit trickier, right? So this is going to be in I'm going to keep this. I'm going to keep this one in Qiskit because this was done. The paper was done in Qiskit as well. So I think where was? Can I? So now I have to find which one was my code, which is the last modified. Is it 2 months ago? A month ago? A month ago. Nisk Grover archive. But is this my code or is their code? That looks like my code. That looks like my code. Yeah. Okay, so we'll try to copy import whatever is meaningful. They are also Strangeworks is also working on a Jupyter notebook integration, but I'm not sure how it's going to look like. I kind of like to have this as a as a project though, because then it's easy to share with people. And so we're gonna be basically what I will do is I will see so. Imports for noise. We are not going to need that. We're not going to load our account. And we're not going to get those providers because you can't do that yet. So you only have access to simulators. So we'll just basically stick to the Chasm simulator. And so what we're going to do then, so what are we doing here? Quantum circuit. Is it all used anywhere? So let's just copy stuff and then we'll see what's used and what's not used, okay? We'll kind of clean it up. So we'll kind of clean it up as we go. So this is the R-Toffoli, I remember that. The R-Toffoli. So yeah, this is the Oracle. But this is the Oracle with a simulated verdicts, I think. With the virtual verdicts, it was called virtual verdicts. And the R-Toffoli, that's one of the Toffoli implementations. Then there was the R-Toffoli M. So this is the R-Toffoli. There was one of those. So there are different versions of R-Toffelis that we could play with. This is the R-Toff F, and I probably should do this in a nicer way. So I could pack all those into actual functions. So R-Toffoli. I don't know what was the S. I think that's the one that has the swaps exactly. Swaps with a swap built in there. Not gonna draw. We can draw though, but I figured it out yesterday. So actually, what you can do with Strangeworks is because apparently the way this works is it's a bit dirty. I mean, the way this output is captured here, it's not something you can easily. I don't know exactly how this is implemented, but it's not something that works right away here. So, but what you have is from the Strangeworks wrapper. I think that's from Strangeworks. You have the extract diagram. I think it's called extract diagram, and I think you can basically use these and say, I wanna extract, for example, can I just extract the TOF-S? TOF-S, not TOF-S gate. So you can extract diagram RTOF M. I think you can do that. And this is basically RTOF S of M and RTOF. And I think this is basically gonna, if this works well, let's try. So if this works well, nothing breaks, I think it extracts those diagrams into different sections in the output of the execution in here. Yeah, here you go. It's pretty cool. Okay, here's something broke. What broke in here? Start time RTOF S. It's not defined. Isn't it? It's TOF-S. No problem. No problem at all. Good. So we got all these. And now we start with the actual circuit. So amplitude amplification. Yeah, you see, that's pretty neat. Okay, so you can at least see what's kind of going on everywhere and inspect that. And you can, okay, you can actually hide those things. That's pretty cool. And you can even give it a label. I think you could give it a label, circuit diagram. But okay, let's see. Let's finish up with a copy paste, first, and we're gonna extract the diagram, and we're gonna extract the diagram for AA. Why? So keyskid circuit draw method. How is this done? So we can take a look at the implementation here and see why this easily work. Draw. Can I see the implementation in here? Or should I just go to the source code? Your page source? No. Source. Oh yeah, here you have the. Okay, we can take a look at this later. We can read at this and see how this is being implemented. And why doesn't this work here? But this is pretty. It comes in pretty handy. Good. So what else are we doing? Now there's the actual circuit here where we do this 2 times and we have the measurements and whatnot. So we're gonna go. I'll document that in a better way. Okay, so I'm just copy pasting so I have the code in here first. And so it's gonna be circuit for these. Good. And then we've got the jobs in here. So we're not gonna run it on this. We're gonna run it in the simulator. So we're just gonna simulator histogram, simulator results. Where's the simulator result? Simulator job. So I need to kind of copy these. Okay, so AA is not RTOF gate is not defined. What the hell? Where? What failed here? AA RTOF gate. Okay. I didn't add that part of the RTOF gate. TOF-S gate. There's no RTOF gate. And here. Okay, so this is the RTOF. What is RTOF? That's that first one. Okay. So this is no, sorry, not these. Art of Gate. I should copy paste that here. Cool. So we're gonna be finishing now, so I didn't want to spend too much time. Just wanted to show you guys a little bit around the platform as I copy paste things, extract a diagram, and where are we now? So running these, and we're at AA, and now we wanted to get the simulator stuff up and running. Simulator stuff up and running. So let's simulate. Let's simulate. So we're doing the circuit with a simulator. That amount of shots. Then we're getting the simulator results. I think we don't need that. I think this catches it all. Let's try. I think that's the neat part of the whole thing is that of Strangeworks is that they just do the job for you with that. So you can specify, but I think they catch the execute results and they print the histogram for you. Because then there's a bunch of error correction stuff in here, which I think I'm going to leave out of for now of the project. Because it's getting basically the noise model from a device, which I can't do at Strangeworks right now, but I'll be able to. I mean, I'll be able to soon, and if not, I just can also make up a noise model. But I'll leave that out for the moment. So this is it's going to be half done because this is just to demonstrate the measurement error correction. By the way, did this work out well? Circuit append, AA inst. Have I missed something? Where's AA inst? I didn't do that, so that's not good. A. Here we go. I'll clean that up. I'll make it into maybe a class or something. I don't know. I have to think about what's a cleaner way to do this. This is just simply like copy paste. Okay. I just wanted to, and then it's missing the error correction. So it's missing the to do here at the end. Missing. So missing the measurement error correction part. Okay, so here we've got a circuit. We've got the different circuits of extracted. The final one, I kind of like. I really like the fact that you can just print all those things and kind of basically then take a look at the stuff. Okay, here you go, and you've got the transpiled circuit. You can take a look at the circuit resources as well. You can take a look at the chasm implementation, and down here we've got the result. Beautiful, and it works. That's beautiful. That's perfect. And you even have the table. It's just, that's really cool. You kind of have a bit of all the resources packed into one page, all the sort of the reporting packed into one page. And I think that's actually, this has a lot of potential. And I think there's a chance in here for a lot of interesting things that you can do to kind of debug stuff. And I don't know, I'm having, I think this whole output concept is really, really cool. It's got a lot of, I sense there's a lot of potential in here. You could play with that somehow. Yeah, but here is it. So we've copied now. So we've copied these. We've ported these. Not everything, but most of it. I'm not gonna copy over the stuff that's coming from the authors in here because it's their code. I'll probably ask them if I can do that. That would be nice because it's their implementation as well. Counting is on the way. This is on the way. I can take a look at the sessions I did from Qiskit Live, see if there's anything worth porting. Sorry, this is what I did, and I think that's it basically, right? So where am I in here? If I go back to projects, so the NIST machines, this is work in progress. This is work in progress. This is work in progress. It's everything work in progress. But I'm happy. I'm happy with the current setup. I'm happy with the current setup. You know what's really cool about the platform as well? If you can go, I hope it works, because this is, again, like it's being developed as we speak. And so there's, they're breaking things quite quickly and fixing them quite quickly because they're just really adapting a lot of the things right now. But if you go to news, you can actually, cool. So it's plugged to the news, and there's already the Google's head of quantum computing hardware resigns. Nice. So you kind of have news in here, and you've got research. That's awesome, because you can basically go to the just take the paper and start working on a project based on a paper, right? You can filter, but you probably can't search yet. But you can filter by vendor, by category. So what about search? If I apply the search. Yeah, I'll have to take a look at it, but it's probably, so that's really cool that you kind of have everything packed into one place. Not even talking about the integration with the quantum stack exchange. That's just the cherry on top of the cake. Cool. But I mean, you've got the library here. They're improving on these a lot. So you kind of have sample projects you can copy over to your private library, share stuff. There's a bunch of things here that have a lot of potential. So I'll leave it here, though. As I said, it's porting week, so I'm going to still be working a couple more days this week, I guess, on finishing up some of these things. And then I just think I promised to start something about the quantum internet, but I'm still going to put it off for a week or two, I think, because I want to leave those projects kind of finished, and I want to work on the documentation of those as well, and kind of go through this, refresh the material. It feels like I need a week of sit back and kind of let things soak in terms of what I'm doing here. Especially, I've got some interesting ideas for the quantum counting, which is a little bit of sort of a better idea of an idea that seems to me that it could work better than the current algorithm. Then there's the Rubik's sphere as well. Just a bunch of stuff. I'm sorry if I sound too excited about these things. I tend to be this way. Anyway, I hope you enjoyed the video, and stay tuned for more.